Hi, Chem Peeps. I'm continuing our final exam review, and we're going to talk about the periodic table and the trends that it has today. As I have said in my other videos, remember you have a whole year's worth of material that the teacher has to assess you on in a very short testing period. And so you really have to be selective. I do recommend going back and looking at my teaching videos up to this point, but this is what I put on my final exam, somewhere between 75 and 100 multiple choice questions. Some required application, some was just understanding. And so this is what I put on my final exam. So looking at the questions on the far right here, we have question 36, and it says, the alkaline earth metals form what oxidation value? So I'm actually assessing two content areas. One, do you know the family names on the periodic table? And do you know the trend for the oxidation numbers or the charges? And so if we look at this chart here that I have, this was in my teaching instruction. The alkaline earth metals are going to be found right here in column 2. So just real quickly, column 1 is the alkaline metals, then column 2 is the alkaline earth, and then this big block here are the transition metals, and then we have family 17, which is the halogens, and 18, which is the noble gases. Then we have the 4Ds, which is the lanthanide series, and then we have the last 5D section, which is going to be the actinide series. Again, there's like this imaginary divide that goes down through here, and on this side we have the metals, and on this side we have the non-metals. And you can see that because of the trends that they do have, they have common charges. So if we come back to family 2, their charge or oxidation state is going to be a +2. So if you need more of a review than what I just did there, you need to go back to the video on my periodic tables trends. And so our answer here, our answer here is going to be B. All right. So question 38 says, Dmitri Mendeleev organized the first periodic table. So when I'm teaching the periodic table, we talk about the origin of it. Dmitri Mendeleev was the first to organize by increasing weights and common properties or common traits. And so he is known for D. Then Henry Moseley came along because there were inconsistencies in using the method that Mendeleev used. And so about the time Moseley organized the elements, we had discovered subatomic particles, the electrons, protons, and neutrons. And so he used the proton number, or what we call the atomic number. So he's most known. He also used traits, but that wasn't new. He was known from going from atomic mass to atomic number. And so that's what he's most known for. 40. How does the periodic table have periodicity? Periodicity goes along with the periodic law that when elements are organized by increasing atomic number and by common traits, those traits will repeat themselves over and over again. So the alkaline earth metals, they all have a +2 charge. The alkaline earth metals are all metals, and so forth and so on. So that because we come back to family 2, over and over on the periodic table, we see common traits there. So if we look here, they're not in alphabetical order. Yes, B, they do repeat themselves. And they're not by increasing weight. There are some that are not in that way. And they're not grouped by properties. It just so happens their properties do repeat. So B is the answer there. 41, 42, and 43 have to do with the different periodic trends that I talked about, specifically atomic radii, ionization energy, and electronegativity. Over here on the left, I have charts explaining those from my video. And so we're talking about atomic size or atomic radii in 41, and it wants to know why oxygen has a smaller atomic size than nitrogen. So I'm just going to quickly go over this. We have oxygen about here and nitrogen about here. And so as we go across a period and up a family, we see that the size decreases. And the reason for that, if we look right here, It is because there's a stronger electron pull. Same number of energy levels, but I have an increasing number of protons pulling on electrons at the same distance, and so it grows smaller. So answer A is the correct answer there. Okay, so let's go to question 42, which is going to be ionization energy, and it's asking the ionization energy of magnesium is larger than calcium because why? So if we look real closely here at this chart, I may have to, let's see. So magnesium is about here, and calcium is below it. And you can see as we go up, we're going to have increasing ionization energy, and that's a family explanation. So let's see what it says. The energy decreases because there's more and more energy levels, so the electron is further down. So that's talking about down the family. So it's just going to be the reverse. They're closer. So there is a, if we look at A, it says the electrons are closer to the nucleus. That is true. There's a stronger electron-proton pull. That is true. The atom is smaller. That is true too. So the answer here is D. So be very careful about reading all the selections and ruling them out. Okay, 43 says, which of the following elements have the smallest and largest electronegativity in that order? So if we look at the electronegativity, we have a selection of elements here. So real quickly, this is going to have the largest electronegativity, and this is going to have the smallest. So I'm going to look by proximity where we have these elements. Cesium is down here, and then we have hydrogen, which is up here. Oops, hydrogen's up here. We have iron here in the middle. We have iridium, which is here in the middle. We have oxygen, which is up here, and aluminum, which is about here. So the one that's going to be the largest is going to be the oxygen, and the one that's going to be the smallest is going to be the cesium, and so that is going to be D. All right, let's look at the last question that I had on my test in this category. Up here at 35, it says the halogens are highly reactive because, and why is that? So when we look at the periodic table, I'm just going to quickly make this bigger here. When we look at the periodic table, we have reactive families. And so I'm going to quickly erase this so that we can talk about this. The two most reactive families are actually on the ends, not the noble gases. They don't react, but the halogens and the alkali metals. And that is because they're so close to having an octet. They form a +1 charge in the alkali metals because they lose an electron to get that octet. And the halogens form a -1 charge because they gain an electron to get an octet. And they do that through bonding. And so when we go back to the question, it's talking about the halogens, the ones with the -1 charge in family 17, and they're so reactive because they're so close to that coveted octet. It's because they need to gain an electron. Okay, and so that is my review on the periodic table. I hope that helps. Give me a like, share it, save it, and leave me a comment if you need more or if it was helpful. All right, I'll see you on the next video.